Now that we know all about web element locators, let's use them for test automation. When it comes to automating web UI tests, there are two main categories of tools: codeless and coded. Codeless tools enable testers to write test procedures using some sort of form, builder, or recorder without the use of a programming language. These tools are ideal for manual testers who are great at testing but not strong at programming. Popular codeless testing tools include Selenium IDE, SmartBear Test Complete, and TestCraft, but there are many more available. Another interesting tool that is halfway between coded and codeless is Cycle Automation, which provides out-of-the-box Gherkin steps for web UI interactions. Whatever the tool, they all will need to find elements using locators. Some tools require the users to enter locators for desired elements, while other tools generate locators during test recording sessions. If you are using a codeless tool, follow the tool's docs and best practices for how to handle locators, and apply what you have learned in this course to write good locators when necessary. Coded automation tools essentially mean test automation frameworks and programming packages. To use them, you will need software development skills. For web UI testing, WebDriver is the de facto standard protocol. In fact, many codeless and even other coded tools use WebDriver under the hood. There are a number of packages that either implement WebDriver directly or bundle and improve an existing implementation. The most popular package is by far Selenium WebDriver, but others include Appium, Protractor, and WebDriver IO. WebDriver can be used by any programming language for which it has bindings, such as Java, JavaScript, C#, Ruby, and Python, and as part of any test framework, such as JUnit, NUnit, Mocha, Cucumber, or PyTest. Be careful with words, though. WebDriver is not a test framework itself, but rather an interface that can be used by frameworks. For example, I could write PyTest methods in Python that make calls to Selenium WebDriver. When writing test automation code, you as the programmer must handle your own locators. Let's write a basic test together in Java using JUnit and Selenium WebDriver to see it all come together. Our test will be a simple DuckDuckGo search. Simply go to the DuckDuckGo homepage, search for a phrase, and make sure the results page shows results related to the search phrase. Here, I already have a Java project with a test stub named Simple Web Test. There are setup and cleanup methods for handling the WebDriver. Every time I write a new test, I start at the top with my steps and progress down into the code. First, we'll need to load the DuckDuckGo homepage, and that's a simple WebDriver call, like this. Next, I'll need to find the elements for the search bar so I can enter the search phrase and click the search button. I'll switch over to the DuckDuckGo homepage and use Chrome DevTools to find the elements I need. Here's the input search bar. Luckily, it has both an ID and a name. I'm going to use the name simply because it's shorter. Back over to my Java code, I can write WebDriver calls like this. Web element search input equals driver dot find element by name Q. And once I have the element, I can say search input, send keys, whatever phrase I want. I'm also going to add a wait condition. Wait until the expected conditions for visibility of elements located by name Q. This will wait to get the element until the element has appeared on the page. Now I need to click the search button. Back over to the DuckDuckGo page. I want to find this little hourglass input button. Here, it has an ID. Search button homepage. Nice. Back over to my Java code. Web elements, search button equals driver find elements by ID, search button homepage. Once I have the element, search button, click. Now, even though we have these two elements, there's actually an important step I forgot when I grabbed the locators. I didn't verify that these two were actually unique. So let's do that now real quick so we don't get into trouble. I'll switch over to DuckDuckGo homepage again, and I've got my Chrome DevTools. Let's make sure that name Q is unique. I'll use a CSS selector. Name equals Q, and sure enough, that's the only one on the page. I'll also double check my ID via CSS selector. And again, 1 of 1 returned, I should be good to go. After entering the search, I'll need to check the results on the results page. However, I need to wait for the results page to load before I can get the links on it to make sure that each one contains the word panda to match to our search phrase. I'm going to do some more expected conditions. Wait until the title contains my search phrase. The next thing I want to wait for are the links themselves, so I'll need to go get a locator for those. Back at DuckDuckGo, if I enter my search phrase, I can use Chrome DevTools to find these link elements, and they're here. What I notice is that they are inside of this div for the different results bodies. And then down as a descendant, there's the hyperlink with the class of result A. So in this case, I'll want to use a CSS selector to make sure I get the right elements. So I'll grab the class name here. That was for a div element. And then under that, I want to make sure I get the proper result link. And boom, this CSS selector here returns those 10 links that I need. So back over to my Java code, I'll say wait until visibility of the element located by CSS selector for the locator I just found. Once the results page displays all the results links, I'll want to check the text of each link to make sure it contains my search phrase. In order to do that, I'll need to get a list of web element objects because there will be more than one in my page. And I'll say driver.find elements plural by the same CSS selector for those links. Once I have the link objects, I can iterate through each one and do an assertion based on text matching. So for each web element in my result links, assert true that the link getText matches a regular expression ignoring case for the phrase panda. Now that our search test is complete, let's run it to make sure it works. Everything here is automated. And bam, look at that. Passing test. Although this code works, it does not follow best practices. Take a look at these locators. This by name locator for the search input is duplicated. And so is this CSS selector for our result links. Furthermore, the WebDriver calls are fairly low level, and not very much of this is self-documenting. The best practice for locators, regardless of the language or the framework, is to separate them as a concern. Locators will naturally cluster around related elements. Test for a feature will likely use those clusters of locators repeatedly. Therefore, it makes sense to group locators together somewhere in the code, most likely in their own class or module, so they can most easily be reused. Arguably, the most popular design pattern for modeling web UI interactions for test automation is called the page object model. Using page object model, a web page is modeled as a class. For example, here is a page object that models the DuckDuckGo homepage. The page object class contains a locator object for each element needed for testing. These should look familiar: our search input by name and our search button by ID. Each locator is given that intuitive name. They should also be treated as immutable, though sometimes it might be helpful to write a builder method for a locator in case the locator needs some sort of parameters. The page object class also contains what we call action methods that use the locators to interact with the page under test. Here we can see our load page method loads the web page by URL, and the search method not only waits for the search input to appear, but then gets the search input, sends the phrase, and then clicks the search button, all within one call. These intuitive names make actions self-documenting. Also, it's fairly common practice to have a base page, like our abstract page here. This just provides some basic attributes to be shared by all pages. If we rewrite our test using page objects, we can see how much more readable and reusable the code becomes. For larger test automation projects, I strongly recommend the screenplay pattern, which can be seen as a solid refactoring of the page object model. The screenplay pattern further separates concerns by splitting locators and interactions into separate classes for even greater reusability and composability. Check out frameworks like Serenity BDD and Serenity JS to learn more about the screenplay pattern. You should always treat test automation code like living code. Whenever the page under test changes, its locators most likely will also need to be changed. This maintenance overhead is unfortunately unavoidable because testing is dependent upon the product. When locators are treated as separate concerns, however, like with the aforementioned design patterns, then maintenance is straightforward. Just update the locators in one place. Some tools and frameworks, like the new Selenium IDE, have a nifty feature whereby an element can have multiple locators for failover, in case some locators don't work in the future. Other tools, like Mabel and Testim, claim to use AI to make locators self-healing whenever UI changes break tests. You can also check out this Test Automation University course named AI for Element Selection, Erasing the Pain of Fragile Test Scripts, which teaches how to use AI for finding visual locators. Regardless of the tool used, locator maintenance will be inevitable.